In this video I'll be creating an image in my favourite graphics program and then converting that image to FreeCAD by loading it via a macro and then allowing the macro to render that image to a sketch as a series of holes, circles, hexagons, or whatever shape you want, so I can actually create a pad or a pocket to make an interesting project. So I'll just create a small pad around this in my sketcher, jump over to my part design, flip this around so you can see what's happening, and then we'll select the sketch, pad that, and there you can see we've got a nice interesting drilling pattern or machining pattern that we can use. This works for more complex images as well. So if I come out of this, let's get rid of our sketch, create a new sketch, XY plane, okay, and let's go back to our macro, and I'm going to load a different image in here. I'm going to load the image for Australia. So it's a bit more complex, it'll take a bit more time to actually calculate, but we'll give it a go. There we go, the image is now rendered on the screen. Let me just bring it around to the right orientation. As you can see, we now have got Australia rendered as a pattern that we can pad or pocket into something a bit interesting. Okay, so what I'm going to do is show you the theory behind that, then I'm going to go through how to create the macro to actually allow you to do this. So for this exercise it's best to use a smaller sized image, because what we're going to have to do is actually load that image into memory and then traverse the pixels in that image to actually find out which image is populated with colour and actually lift that colour out and use that as a coordinate for our image that's going to be recreated in FreeCAD. Now if you noticed before, if I flip back to FreeCAD and I'll jump back into here and load the simple map. Here we go, that's already done. So there's our A sitting there. So you notice that there is spacing between each of these. So the top part of this A is not 4 pixels long. So what I've actually done is actually, if I jump back to GIMP and actually zoom in on these. So I've got my brush at 1 pixel here, so you can see each of these squares going along is 1 pixel long. So we've got around about 6 pixels along the top, but you'll notice that we've only got 4 pixels here. And the reason why is that we're actually skipping a number of pixels that's predefined in our script. So what I do is that I will load this in via FreeCAD into memory. I will then extract out the pixel data and I will then go into a loop that actually loops across the screen from left to right, working from top to bottom, and we'll work our way across in steps of around about 2 or 3 pixels. So every third pixel it will be picked up. So this one here will be picked up, then it will go 3 more, picked up, 3 more, picked up again, and we'll keep on working our way across in threes until we find a pixel that has a color within it. So this will be 0 color, and when we get to here, this will actually have a value. When it has a value, it will be picked up and actually placed in a list of coordinates that we will actually access later, or it will even actually just plot it to the screen. You can do it either way. We can actually build a list of coordinates first and then plot it to the screen, or you can actually save that process in time and plot it as you go. So as we're going across, we'll pick up another pixel, and then it will start picking up blank space again. So all those pixels it will pick up, it will use as coordinates to actually create a circle or a shape at that point. And then we move on to the next line of pixels and work our way across the same steps, trying to pick up pixels as we go along. And then also we start picking up pixels, creating our coordinates, plotting shapes to screen in our sketch, and then we stop. And we carry on that all the way down our object until we get to the bottom. And by doing that, we get this nice representation of our image. Because if we did it a pixel at a time, then it will be all mashed together. And now we could have this as just an outline. So the inside of this could be transparent and just the outline of the A. And then we could work across pixels, but that process I would actually go a pixel at a time to try and find the outline. So we can work our way from the left to the right, picking up pixels, and the minute we get to this point, we can actually create a shape at that point in our FreeCAD document at that coordinate, and actually plot a shape there. And of course, when we move along, because this bit will be, say this bit will be transparent, say in here it will be transparent. I haven't placed it, I've just done it white for the time being. I haven't picked a transparent current to say it's just our outline. Then when we get into here, we'll stop picking up pixels and won't be plotting anything to the screen. So we'll end up with just an outline rather than a filled shape. And that's the same for all our other shapes. We do exactly the same thing, even the most complex ones. For this one, it's best to keep the shapes small. So these are, if I go to image, scale image, you can actually see the actual shape, the size of the shape. This is 32 by 32 pixels. The more complex one, scale image, is 115 by 173. The reason why I kept them small is because of processing power, and I'm also on a very slow machine. So everything I do here will be probably the machine that I'm running on is around about, I would say, 8 years old. I seriously need an upgrade. So obviously, if you're running on a faster machine, I think even a Raspberry Pi will do this quicker than what I'm running on here. So yeah, so mileage may vary. Okay, so let's start creating this macro. So I'm going to start in macros. I'm going to go to the macros, and I'm going to create a macro. And I'm going to give it a file name. And I'm going to call it load image to FreeCAD sketch. So a bit descriptive. Okay, so we're editing our macro now. I haven't actually got anything open, any documents or scenes open in FreeCAD at the moment. We just can concentrate on the macro to get the basics down. Now, what I need to do is also get a couple of windows open like usual. I always start from the beginning. So if we go to view panels, and we want the Python console, and view panels, and we want the report view. Looking at is loading an image and collecting the pixel data. So we're going to break it into stages. So the first stage is actually get the image in there and get it ready to use. And to do that, obviously we need an image. My images are actually kept in my dev folder, and they're in FreeCAD and in macros, and in there I've got an image directory of images in there. Now what I've done is changed the location of my macros directory in FreeCAD. So if I go back to macros and go to macros, down here you can see the user macro location, and that's where I'm storing my images. So that will be different to your system, but you can change that to wherever you want. Obviously, if you've got macros there at the moment and you change the directory, you'll see them disappear, but they will still be there on your system. So you're just going to have to move them. Simple as that. So actually, in here in this home oranges dev FreeCAD macro, I've got a images folder, and I'm going to use my smallest one, which is a small map PNG. So I need this location, and I'm going to assign this to a variable. So I'm going to call the variable image location equals, and then in quotes I'm going to place whereabouts it is. So that there is a plain variable declaration. I don't want the semicolon on the end, because I keep forgetting I'm in Python, not in C or C#. So that's the image location, and I can print that using the command print image location. So that there is actually assigned that variable with the image location, so we can use that now. Now we've got the file location to the image itself, we need to actually load that into memory, and therefore we can actually pull out some extra data from that image, including the height and the width, which we need for traversing the pixels, and the actual pixel data itself, and also what the channel information for a pixel is, and we'll come to why that's important later. So to do that, we need a library. Now the library we're going to use is the actual Python image library that comes packaged with Python anyway, so we don't have to worry about installing it. So from Python image library, pil import image. So we've imported the image namespace from the Python image library there, and therefore we can actually use that namespace in here. So we will now create a variable. I'm going to call it img, and I'm going to load that actually the image. So image dot, I believe it's load, and then now we open the bracket and pass in the image location. So that's good, and what I'm going to do is I'm going to now add a print statement, and I'm going to have a check to see if that image has a size. So that has no attribute load. So if we find that issue, what we can do is if I come down to here and type in image dot, and let's see what we got. We haven't actually got anything there for that, and that's probably because we haven't actually got the library available. So if I take that line, place it into our Python console, let's try that again. Image dot, there we go. So we've got our different commands there. So it looks like we haven't got load, so it probably is an open or something like that. So let's try that, open. There we go. So we can actually see what that needs. So there we go. So that tells you about what it does. So let's try that. Let's clear this console. So down here it's saying that there's no such file or directory, and that is because I just need to make that images. So now it's come back as tuple object not callable, and that's because I'm doing a size on there as a function, so open and close brackets are functions, so if I hit that again I should pull back a size. So that size, you can see our previous error message said tuple object is not callable, so I was trying to call that image.size, and image.size is, by that message there, is a tuple that's pulled back. So a tuple is an actual collection that has a number of items in there, and it's a zero base index, so 0 in this tuple will be 36 and 1 will be 36. So you're looking at X and Y sizes there. So that's the width and the height. So to pull back the width, the first one, we use 0, and you can see that's pull back 36. So it's worth actually assigning these up to image width equals img dot size square bracket 0, and image height equals img dot size square bracket 1. So that's the width and height all done there for you. Next we need to load the pixel data, so we need to actually go in and actually get the pixels from that image, and to do that I need to actually load the actual pixel data. I know the image is open, the actual pixel data isn't loaded as of yet, and if we look back at image.open, so you can see from there this is a lazy operation. This function identifies the file, but the file remains open and the actual image data is not read from the file until you try to process the data. By issuing the command .load on that, will actually load that data into that actual variable and load all the pixel data in so we can actually use it. So we'll do that now. So that should have loaded our data. So we can test if the image is actually been loaded now by just getting the first pixel. So we need to actually get the data in a list to actually check that. So we're going to have to create a list. So this will hold our pixel data, and we need to pass in img dot get data, and then open close brackets because that's a function. So what will happen, it will create a list and it will transfer the image data that's in the image to that list. So if we print the length of our list now, so if I use print bracket len and then pass in the list of the pixels, that gives us the length of how many pixels we've got in our list. And if we go back and print the image width and also the image height, so we've got 36 by 36, so multiplying those together will equals 1296. So we've got our dimensions there. Also we'll need to know what's in the pixel, what the actual pixel data contains, because there is a difference between supplying a grayscale or black and white picture to supplying a colour one. At the moment we're working with a black and white picture, so we'll only have one channel, and I can show you that by just going into print, and because our list is a zero based index, so if I go 0, that will be the first pixel, and 1295 will be our last pixel, because we've got 100, because we've got 1296 pixels in there, so 0 base 1295. So if I print our first pixel, which is 0, and we can see that we have 0 for our colour. So the first pixel colour is 0. Now, why isn't this RGBA or RGB, red, green, blue? That's because our image itself is a black and white image, so it only needs one channel, and that's intensity. So that channel is actually kept for intensity. So if I go back and go to my image, the small map, you can see it's black and white. So depending on how intense these pixels are, we'll show you the actual how grey that pixel is. Now for something like the star, and considering it's a PNG as well, so it's a coloured PNG, so it's more than likely has an alpha channel, we'll get red, green, blue and alpha. And we'll get something called a tuple. So if we go back to our code, and I can show you that. So if I change that to star, so at the moment we've got 0. And now if I execute that, you can see we get a tuple back. So tuple is multiple, and we have red, green, blue and alpha. So this is important when we actually do our comparison of picking up our pixels to figure out which one is populated and which one is not with colour, that we need to actually remember that we're going to be comparing either an integer 0 or a tuple of 4 zeros to do the comparison. So for the time being, we're going to actually use that as our colour to ignore. So that's the very first pixel in our image, LST0. So I'm going to assign that to a variable. Later on we'll change that, and we would have to rebuild the actual variable itself if we want to keep this as generic as possible, because you cannot compare an integer value to a tuple value, so you can't use this grayscale to compare to a color, because the actual channel is constructed differently. One's an integer and one's a tuple, and those won't compare together. So if, for instance, our image was a black image, a black mask, and you would actually remove, say, the star or the A in the middle, obviously pixel 0 wouldn't be our color to ignore, so we would have to actually create the color to ignore. If we just create a variable, say ignore color, color equals 0, then when we do a comparison on that, it will be fine with grayscale images. But anything like RGBA or RGB, then you cannot compare 0 to a tuple, because you'll either get an error or it'll come back false. But we'll tackle that in the future, because we're going to get into something that's not mutable. You can't actually add to a tuple, you can only overwrite it, so we have to do a bit of coding around that. But we'll get to that in the future. But for the time being, I'm going to say my ignore color is the very first pixel in our list. So the very first pixel at the top. So that will be here. So we pick up this pixel, and that's going to be our ignore pixel. So this is a color we're going to be ignoring. So let's get rid of these. Don't need those prints anymore. So we've got our image width, we've got our pixel data, and we've got our ignore pixel. So now we've got all those, we can actually start creating the actual image in FreeCAD by using a for loop. So what we're going to have to do is traverse the image, starting from the top, working our way down to the bottom, and every step we'll work our way across. Now we're going to use a for loop for that one. I think we'll stop there for the time being and have a look at actually doing that in our next video. The link is in the description below if you need it. If you like what you're seeing, please subscribe to my site, and also I have a Ko-Fi site where you can actually donate a few pence or a few pounds, dollars, or whatever your currency is, and that's at ko-fi.com/mang0, and there you'll be able to help me fund my site and all the money that I actually get from any funds will actually get pushed back into the channel. Thanks a lot for watching and subscribing. I'll see you next time.